Welcome to Math 8, Unit 3, Lesson 7 homework help. We're going to talk first about using slope-intercept form and actually writing equations in that slope-intercept form when we're given enough information to be able to work with that. So the very first thing we want to look at is right here. We're supposed to complete these lines. So we want to write this equation right here. Now I'm going to put some notes over here. We need the equation y is equal to m times x plus b. Now, a quick review for this, just keep watching over here on the right side of the screen. I'm going to keep working on this and talk to you a little bit about what it means to have slope-intercept form. First off, I want to change a couple of things on here. I want to change the m and the b to different colors simply for the fact that it's that big of a deal. M, I'll go ahead and make one color, and we know that m is going to be called slope. B, I'll go ahead and make that a different color, is going to be your y-intercept. And those are two different colors, and the x and the y are two different colors because they are all going to represent different things. X and y are the same color because they represent the ordered pairs. When we talk about, try and find red again. When we talk about that ordered pair, x and y being that ordered pair, I don't know why it's not disappearing, sorry, but x and y as an ordered pair is what we call a solution for the line, meaning that when I substitute that x coordinate and the y coordinate into the equation, if the equation comes out true, then that ordered pair is definitely a solution or on that line. If it does not come out true, then it's wrong. The slope is blue, and notice that only the m is blue. That's because the slope is completely by itself. Slope is not m times x or mx. Slope is simply a completely and totally m. These two variables mean that we're actually multiplying m slope times the x coordinate. And then b is separate and different from that because b is the y-intercept. It's a separate value from there. And I keep talking about y-intercept. The name that we've known, or that we now know y-intercept from, make that a little bit darker, is also called the vertical intercept. So we call it vertical, or when we're talking about vertical, we're talking about on the y-axis. So now let's see, how do I actually use these? When I go back to my form here and I talk about y is equal to m times x plus b, I'm looking at this blank right here is the m coordinate, or is the slope, and this blank over here is b. It's my y-intercept. I know that m is slope, y-intercept is b, so now it's simply a standard of just substituting. I would put 1/5 in this box, and I would put 2 into this box. Let's go ahead and apply the next problem number, letter b. Slope is m, y-intercept is b. This box gets m because it's the coefficient of x. This box gets b because that's the y-intercept, it's the constant. Substitute my values, 3/5 here, 3 here. Cool, I think you can do letter C on your own. Now, what about the next part of it? How do I know what the next coordinates are with the ordered pairs? Well, the cool thing about having this equation is I also have a formula that I can work with. I now have the equation right here of y is equal to 1/5 times the x coordinate plus 2, which means that this line has a slope of 1/5 and it has a y-intercept of 0, 2. Now our ordered pair that we're talking about, it's kind of, this will hopefully be an oh my gosh aha moment. If I know that my y coordinate is 2, I can substitute y and change it to a 2, and then I'm left to solving for x. So now the question is, how do I solve for x? Well, let's eliminate first the constant by subtracting 2 from the expression on the right, keeping equality using the subtraction property of equality. I subtract 2 from both expressions. That one also equals 0, so now I'm left with 0 equals 1/5 x. There's this thing called the zero product property that says anything I multiply by 0 equals 0. That must mean that over here, x must equal 0. in order to make this true. And I know that the ordered pair 0, 2 is the accurate answer for this situation. Now, how do I find the other one when x is 5? Well, the same thing. I use substitution, and then I solve the equation. So when I substitute this time, I'm not substituting for y, because this time I have an x coordinate. Y is equal to 1/5 of the x coordinate 5 plus 2. And then I simplify. 1/5 of 5 is 1. 1 plus 2 makes y equal to 3. And there's my value. Okay, so what would I do with these other ones over here with part B? Well, I use the equation y equals 3/5 of the x coordinate plus 3, and then I would use substitution. In the first part, I'll substitute this equation, y equals 3/5 of 0 plus 3. And then in the second part, I would use y equals 3/5 of x plus 3. In the second part, I have a y coordinate of 6, so I would have 6 is equal to 3/5 of whatever the x coordinate is, plus 3. Solve them, and you'll get those values that fill in for right here and then for right here. Hopefully that gives you a good shot with those. Don't know why that's not working now for me. Next problem. Problem 2, we'll see a graph, and we're supposed to write the equation for this graph. First thing we recognize, height in inches is h, compared to the bamboo plant after t months. So we recognize h is the height, this is our y coordinate, t is the months, this is our x coordinate. Those can be helpful for writing the equation. Remember that when we're writing slope-intercept form, it is y is equal to m times x plus the y-intercept, where m is the slope. So what we need to do is to have this, and I need to be able to fill in the slope and the y-intercept. Notice I don't have the plus sign here because sometimes that y-intercept can be a negative. For right now, we're just going to use the positive. So let's identify these two things. M is the slope. So let's go across here and find some integer points. Here's one here. Here's one here. The change in y compared to the change in x. If I come down right here, I'm going from 30 minus 15, which makes my change in y 15. And then I talk about from here to here, I'm moving from 6 to 1. So the difference between 6 and 1 equals 5, which makes my slope equal to 3. And I can substitute 3 in for m. My b, my y-intercept has to happen right here. Now it looks kind of like it's right in the middle. So I have between the middle of 10 and 15, that's either going to be 12 or 13. I'm just going to say it's 12. I could say 12 and a half, but it's more likely that it's not going to be 12. So I would know that my y-intercept is at 0, 12. But for this is the b term right here. And we only use the b term when we write the equation. We don't put an ordered pair in there. That would just look silly. So how can I use this to help me now? Let's use this information. I'm going to go ahead. Oh, darn it. Here's what I had. I hit the wrong button. I had y was equal to 3 times t plus 12. Now I have to look at those pieces. Remember that, not t, x. I remember that up here I had t is the x coordinate, h is the y coordinate. So now all I have to do is change this to h is equal to 3 times, instead of x, t plus 12. I think you can do the rest. The last part is asking about how many months will the bamboo plant be after 66 inches tall. Well, if I know that the plant is 66 inches tall, that's the same thing as the h coordinate. 66, the height is equal to 3 times the number of months plus 12. I need to be able to solve this equation, figure out what t is equal to figure out how many months. Number 3. little review from lesson 4. In this case, we have two different cakes. We have cake A that's in the table, cake B that's in this relationship. Cake A, we need to be able to figure out the constant of proportionality. Normally, what we would do with this, excuse me, let me back up. I know this is proportional because if I don't have any flour, I probably don't have any sugar either. So that's usually how it goes. When we're talking about these values, we take in a constant proportionality, K is equal to Y divided by X. So in that case, we could say 3/4 divided by 1/2. That's not a very friendly fraction. I can do it. It can work. It makes it a little bit more difficult. I want to change those to whole numbers so that I can see that. That would mean that I can multiply by either 4, because that one's an easy value to 3/4 of 4. That's an easy one to work with. And 1/2 of 4, that's pretty easy. 3/4 of 4 is 3. So if I proportionally scale these by 4 and I scale this one by 4, 1/2 of 4 is going to equal 2. And so my constant proportionality should be 3/2. Now, if it's 3/2, let's think about a different way to do this instead of doing that yucky dividing a fraction by a fraction thing. And let's just look at the simple rate of change. From the first y coordinate to the second y coordinate, we go from 3/4 cups to 3 3/4. That's just an increase of 3 cups. From 1/2 to 2.5 is an increase of 2 cups. Okay, well, what about from here to here? That's an increase of 1/2, and this is an increase of 3/4. And then look, we're right back to this part of 3/4 divided by 1/2. And we know that that equals 3/2, just like we know change in y or change in x is 3/2. Now the question is, what does that mean? Well, it means 3 cups of sugar, or 3 cups of flour for every 2 cups of sugar. Now, how does that compare to part B? Part B tells us that the equation right here is y equals 7/4 x. We know that the y coordinates all represent flour, so this would be 7 cups flour, as evidenced right here, to 4 cups sugar, evidenced right here. Now, understanding that I have these two ratios now, we're comparing 3/2 cups to 7/4 cups. What we're talking about is if you used 4 cups of sugar, how much flour does each recipe need? Well, think again, we have an equation right here for this one. That means that our other equation, we could probably write that one very similar and say that the total number of cups of flour has to be equal to 3/2 cups sugar. And we're right back to that same situation where we use substitution. If we're using 4 cups of sugar, remember sugar is the x, I can substitute y equals 3/2 of 4. And then I could substitute y equals 7/4 of 4. And by doing both of those, I can figure out exactly how many cups I would need for each of the recipes. So when we talk about constant of proportionality for this situation, for each situation, use decimal notation if necessary. That means they want a decimal answer right here. Well, constant proportionality, we already found that. That's y over x. That's our fraction that's inside of each equation. So the first recipe up here, or the first recipe on top for A, 3/2. Don't write 3/2 there because we want decimal notation. Change that to a decimal. Second one, 7/4. Change it to a decimal. Let's see if I can get that off there. All right. Next one, the last question, is going to talk about transformation. One statement to show how two figures are similar by a sequence of transformation. I'm going to leave you with very limited information on here, but understand that when we're talking about similar figures, transformation is the way that we prove that these figures are similar or prove congruence. Keep in mind what's going on here is we're going larger figure to the smaller figure. That means that we want, sorry, that was really loud. We want to move one corresponding point to another. So if we take corresponding H and move it to D, that would be the way that you need to start this out. H to D. Hope this is helpful for you. Thanks for listening. Let me know if you need any help.